Okay. Just finish the question you're working on, and then we'll start the next lesson in 1 minute. So just finish whichever one you're working on. Takeaway? Yeah, of course, yeah. Okay, let's continue now. Next lesson, if you can write this down, rules of logs. Okay, guys, ready? Yep. So, I think in the tutorial, Ishpreet, I remember we were talking about this from one of the questions. Logs would have been useful from one of the questions we had previously, but no matter, we're looking at it now. So the definition of log is basically, I'll give you an example with a number first. So, well, no, I'll just keep them as letters for the moment. Bx. So what that equals is the same thing as this question. You say b to what power will give you the x. So I'll give you an example with some numbers. If I said to you log 2/8, that's like asking the person the question 2 to what power gives 8, yeah. And the answer for that one would be 3. Okay. So that's how logs work. Let's just practice a couple more before we look at them in more detail. So let's see. Just keep that there for a second. Log 10 100. 2. Log 3 81. 4. Yeah. And one more. Log 10 1. 0. Yeah? Yeah, okay. Right, write this down and then we'll have a look at the rules for logs. This one? No. Just the title, which is the lesson. Okay, write that down. This is important because this is basically the definition. Yeah. Oh yes, there are many other rules. Okay. Cold? A little cold today, isn't it? I think this morning it was what, 1 Celsius, 2 Celsius? Oh, 3. Oh, that's not too bad.
It's okay, thank you. Thank you.
She'll have to get used to it. It's only going to get worse. It's only going to get colder and darker. At least you have the break next week. At least you have the break next week. Something to look forward to. Okay, you got that? You look frozen. Hang in there. Okay. Maybe he needs it, yeah.
I don't know, of course.
Okay. Let's have a look at the rules now. Guys, ready? We'll have a look at the rules. So, these rules look very similar. These rules look very similar to the rules for powers. So the first rule. Log B. Guys, no, please, no talking now. Come on. Because these rules are trickier than the last lesson's rules, okay? Log B xy. Does anyone know what this one is?
Log bx plus log c.
Yeah. Bx plus b. Oh, sorry. Just before I go on, I forgot to give you some vocabulary just at this part here. What's the name of this b part of it called? Oh, yeah, good, base. And what would you call the x part? No, that would be most likely called the index if you were to give anything a name. No, not exponent, because that's kind of like.
Important thing.
No, we won't call it the important thing. What? Anything else? No. Well, guys, just generally speaking, if you have some formula and you put the x inside of it, well, yeah, well, that would be the whole thing. Just the number that goes into it.
Object.
Argument, yes. Argument. Yeah. Okay.
What is it? Argument?
Argument, yeah. Argument. Okay. The proof now for this one. So a lot of these proofs work along the same lines. What you do is you say let x equal b to some power and let the y equal b to some other power. So then you have log b xy would equal log b, and x is bn and y is bm. And that would be log b power. What power do we have here? N plus m. Yeah? Now, if you think about the definition, you're saying b to what power gives me b power n plus m. So b to what power gives me b power n plus m? Yeah, n plus m. Obviously, right?
Yeah.
B to what power gives me b power n plus m?
Yes.
N plus m. Now, if I write log bx, b to what power gives me x? Yeah, you have it right here. B to the power of n gives me x. So this guy is n. And then, what's by? Yeah, what's this one? M. So we've ended the proof.
Proved,
Yeah, log xy equals log x plus log y. You see, a lot harder than the previous lesson, but it's good algebra practice for you to have this proof in your notebook, please. So this is the first rule. Okay, you got that?
1 second.
Not yet? Okay. The next rule is so similar, it's not even worth me writing it out fresh. Rule 2 is log x over y. What that equal? Log x minus log y. And the proof, let x equal bm, y equal bm. Log x over y will equal log bn over bm, which will here be n minus m, which becomes minus here, which becomes minus here. So that's the end of proof 2. Now you can do the same thing that I did if you like, if you have a different colour pen. If you want to just save yourself some space. I guess you'll have to write it out again. You got that, Jim? Now, I called the last lesson indices and logs, but I realized I should have called them rules of indices or rules of power. So I'm only telling you this if you look at the video later. I'll just have to rename that rules of indices. And this one is rules of logs. Okay. Right, can I scroll down? Yeah. Rule 3 now. Yeah, that's what I'm thinking. I'll do log b x n, for example. Yeah. That's it. It's n log bx. In other words, you can bring the power down in front. Okay. The proof, log bxn equals log bxxx dot 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 n times. But I can use one of the rules I have proven so far. Which rule can I use now? Oh, come on, I've only proven 2 rules, so it's 50-50 chance. The first rule, yes. Because I can change this into log bx plus etc. There's n of them, isn't there? So here you go, that's the end of this proof. That's n log bx. Okay, so you can write that one down.
This is one rule.
Yeah.
Doesn't
It doesn't split into rule 4, no.
I mean, like, there's a rule if to the power of b, like if b has power. So
Yeah, different books are going to list different rules. I'm just sticking to the ones that I've seen used in the exam. But you're right, there is one is if there's a power on the b. Correct, yeah. Got that? Yeah. Say again?
It can be a test in our exam, like a proof.
No, I won't give you any proofs in the exam. Okay, you got that? Yeah. Can I scroll down? Yeah. Rule 4 now. So now we're getting a little bit trickier. So this one here, log base x argument y, you can change that into 1 over log y in the base and x here. So in other words, if you swap the x and the y, the price you pay is you have to flip it upside down. So I'll just give you a quick example. If you say log 2/8, that will be the same as 1 over log 8/2. Okay. Okay, so let's have a look at the proof here. So, some of you would have seen slightly different rules, or maybe the rules in different order, depending on your high school book. Okay, so some of you may or may not have seen this rule before, but it's a useful rule when you need to swap the two around. Okay? If you need, yeah, it's one of the ways to adjust the base. Yeah. Okay, the proof now. Again, the proof is looking pretty similar. You say let x equal b power n and y equal b power m. See if I can get this, if I remember this. Log bn bm. That's, well, I'll write out xy first. And that's equal to log bn bm. Now this is a little bit tricky, but if you think carefully, you can figure this out. B power n to what power will give me b power m? So b power n to what power will give me b power m? Because that's what this question is posing to us. What is it? M divided by n. Yeah, m over n. Yeah? A little trick here with the fractions. This is the same thing as 1 over n over m. That's a trick with fractions. You know, like if you had a over b, that's equal to 1 over b over a.
Yep.
So, why did I do that? Well, you can see now what I can do is I can change this into log b m bn. B power m to what power gives me b power n? That is n over m, which is what I have here previously. And the reason I did that is so I can make it quite clear now that what I finished up with is y here and x there. Okay, so now the proof is getting quite complicated. Don't worry, proof's not in the exam, it's just good practice of algebra. If you can copy this down, please.
How many rules is it?
One more rule, and then like last time, one more set of sort of definitions like log 1 and so on.
Only the main one.
The main ones, yeah. Okay, write this down, please. You got that? Yeah? Is that a no? There's one more, well, there's two more rules to do, but one of them is just a set of definitions. There's one more formula rule to do. The next rule is the change of base rule. So that's how you can change the base to any base you would like to have. Okay? Can I scroll down now? Yeah. So, rule 5, isn't it? So this is if you have, for example, let's say you have base B, and you would like to change this into a different base, let's say base C. The price you pay for making the change from base B to base C is you divide by log base C of the old base B. Okay, so if you can write that down, and again we'll look at the proof. Yeah. Say again? It's your choice. So C represents any base you would like to have. Yeah. This is rule 5. Oh, but you're right. I wrote 4, didn't I? Rule 5. No. I'm forgetting my Roman numerals. Rule 5. There we go. Okay, yeah. No, sorry, it looks a bit like a power, doesn't it? The x is just the regular x here. Argument x, yeah. Okay, let's have a look at the proof, if I can remember this proof. I think if I remember, we start off by saying let b equal c power n and let x equal c power m. I hope. I guess I'll find out now if I remember how. So log bx then would equal log c power n c power m, which equals m over n. Like in the previous proof, which is log cx over log cb. Oh, that's the end of it. Okay. I guess I do remember how to prove it. Right, so that's the end of that proof. Can you see? Sorry, that's not clear. There's C's there.
Like terms that LG is logarithm of 10.
Ah, LG, yes. And for you, tangent is TG, isn't it? Yeah, no, different symbols here. Because you pronounce the G more in tangent, don't you? Like tangental.
Probably.
Yeah. Right. Can we go on to number 6 now? Yeah. So rule 6 is more like just a list of some things you can and can't do. So for example, log b1 will be 0. Okay. Log bx is only defined if x is positive, okay, because we do not like log b of 0. That is minus infinity, which is bad. And we definitely don't like log b of a negative, because that's not a real number. It's just not a real number. Also, we can't have we don't ever want the base to be 1. The base can't be 1. It doesn't make sense. You know, if I said to you log base 1 of 2, 1 to what power gives me 2? Yeah. Quite impossible. 1, 2, 3, 4, 5. And generally speaking, we prefer the base to be a positive, although it can still make sense if the base is negative. You know, it's not a ridiculous thing to have. Like, for example, if I had log base minus 3, 9, like that's still possible to have an answer. Minus 3 to what power gives me 9? 2. Okay, so it's not totally wrong, but generally we try to keep our bases positive. we prefer. Okay. Couple of other things. Oh, sorry. Can I scroll down? Yeah. So, a couple of other things to note in Rule 6. This is still Rule 6. If I don't write the base, then I understand, of course, that there is a base. It's just I didn't write it. What base do we usually mean? Well, it depends. It depends on what class you're in. So, if you're in chemistry, if you're in maths, or if you're in computer class, not writing the base has a different value. Okay, so in chemistry, if you don't write the base, you usually mean base 10. And the reason for that, does anyone know? What's it to do with? pH. Yeah. Because for the formula you need log base 10 for pH. Okay? In computer class? 2. You would mean base 2. Okay? Because the zeros, ones. And in maths class, no. In a proper maths class is E. Yes. Yeah. Yes. Yes. So on your calculator, just be careful. There might be 3 log buttons: log, ln, and l with a space here and here. So this one's nice because it lets you choose any base. When it's just ln by itself, the base can only be E. And then here, this one is 10 on the calculator. Okay, yeah. So to prevent any confusion, and because you use log in chemistry class and perhaps biology class, whenever I mean base E, I'll always use ln. And I'll use log for base 10 because that's what you use in chemistry.
Can you repeat that?
I'll always use ln when I mean base E.
Yeah.
And log you can use for base 10 because that's what you use in chemistry and biology perhaps too. Okay, let's have a look at some examples now. Can I scroll down? Yep. So the first one, just to warm up, you don't need the calculator. Log base 10, 100. 2. Okay.
1 plus 1, 2.
Yes, indeed. Right. Let's see. Let's simplify this 1 over log base 2 of x. What rule could I use to simplify this?
Log base x.
Yeah, which rule? Yeah, what number is that? That was 4, wasn't it?
Number 4.
Yeah. So this is equal to log x2. Okay. Let's say something a little trickier now. 3 log 7, 343 plus 3 log 7, 343 minus log 749. Now in the exam they sometimes say simplify without using a calculator. So again they want to see the steps. Well, the first step is pretty straightforward. What's the first thing you can do here?
Multiply by 3.
Yeah, or just add these together,
Yeah.
right? You have 3 of them here and 3 of them here, so in total you'll have 6 of them.
It would be interesting if like square, like it would be like square formula, and then we would need to change logarithm.
Yeah, did I actually
x.
give you anyone with squares? I don't think so. Huh?
I think you have missed one more.
Isn't it?
Hmm?
When base and argument becomes is the same number.
Oh,
Yeah.
okay. If you'll feel better to add that in, fine, I can. All right. Log xx
One.
is 1. Okay. Feel better now?
Yes.
All right. Okay, so back to this one. Log 749. Now, why can't I use rule 2? Why can't I use rule 2? What's stopping me from using rule 2? The 6. I can't use rule 2 if I have the 6 in it. So I need to do something else instead. I could do something with the 343. I think that's like 49 times 7, is it? Is it 49 times 7?
Yes.
Yeah.
7 to the power
Yeah.
of 3.
Yeah.
Or I could do 7 to the power of 3.
Yeah.
Yeah. I could work these out. So this would be 7 cubed. And this one here would be 7 squared. Okay, well, it's looking pretty clear now. 7 to what power gives me 7 cubed?
That's 3.
And 7 to what power gives me 7 squared? So 16, isn't it? Again, there are many paths you can take to get into the answer here. Write that one down. You got that?
Yeah.
Yeah? Okay. Last thing to have a look at is the graph of log. Now, in the exam, they're supposed to just keep it to graphs of base E. So that is of the form, just like in the other lesson, A log bx. So once again, 4 possibilities. So if you can get started on drawing the 4 graphs, and we'll add them in. Okay, so the first one again is A is positive and B is positive. So A and B are both positive. The graph looks like this. Okay, yeah. And why is there no graph on the left here?
That's
Positive.
Can't be negative for x, yeah. And what is this value here?
A.
Not this time, I'm afraid. Not this time. Sorry, oh yeah, what's the root here? What's the x value here? No, because we can't have log 0. Nope. Oh, we're getting desperate now. What is it?
Solution.
No. Okay. It is 1 over b. Right? Because you want log 1. Because what's log 1? What's log 1? 0. 0. Log 1 is 0. And you want it to be 0. So you want the inside to be 1. You already have a b in there, don't you? So it has to be 1 over b. Okay, the next one is if we'll say a is positive and b is negative. So the graph will look like this. And that's
1
again
over b.
1 over b, yes. Yes, 1 over b. The next one is if a is negative, but b is positive. So if a is negative and b is positive, oh, getting tired. How the heck does this go? It goes like this. And it flattens off. Once again, 1 over b. And the last one is if a is negative and b is negative. Oh, goodness. No, I think I did. No, I did some. Sorry, wait. No, something's not right. Something's peculiar here. Let me just go back and draw them in again and just think clearly. Oh, come on, you can live with it. I might just end up drawing the same thing, so just don't. I'm just double checking. Is that what? This is what I drew last time, isn't it? Yeah, okay, so that was fine. Okay, that's fine. So it's still okay, alright. So chillax. A is negative, and what did I say? B is positive.
Yeah.
Like this? That's what I did? Yeah, okay, good. A is negative, and B is negative.
Symmetrical.
Too much thinking. Oh, nice. B is negative, so it shoots down, and A is negative, so it's on the left. Yeah, 1 over B again. Yeah. Well, it has to be right because it makes a nice circle in here.
You're checking yourself, yeah? Like putting all numbers inside of it.
No. I was just thinking more deeply about it, that's all. Got that? Yeah. Okay, can I scroll down? Yeah? Not yet? Okay. Yeah, scroll down. So, we have, let's say, y equals 2 log 4x. I want to graph this one. All right. So it goes like this. And this point here? 1 over 4. 1 BCDE, 2 BCDE, 3 OZ, 4 GH, and 5 B. Okay, get started on these though.
I just need to, in the force, I just need to put in the plate.
That's all, yeah, just to practice using your calculator.